In this tutorial, you will understand tool creation and the tool database, learn how to create a roughing toolpath and how to define feeds and speeds, and be introduced to toolpath editing. We'll begin with tool creation. Tools can be created either by right-clicking on the Tools section in the Explorer window or via the ribbon either in the Home area or the dedicated Tools tab. To create a tool, select the desired tool type. In this case, we will select a flat end mill to open the tool definition dialog box. The first page is used to define the cutting portion of the tool. We will call this tool EM20, give it a flute or cut length of 40 mm and a diameter of 20 mm. Once a valid tool is created, it will appear in the graphics window. It can be shaded or unshaded, again via the right-click menu or through the ribbon also. Let's define the number of flutes as 4, but for now we will leave the tool number unassigned. Non-cutting portions of the tool are defined in the Shank tab. We will add a shank of the same diameter and specify a length of 60 mm. Finally, we will add a simple holder from the Holder tab. Add the first holder component, defining an upper diameter of 50 mm and a lower diameter of 40 mm. We'll set a length of 5 mm. Both shanks and holders can be made up of multiple components. So we will add a second component with an upper diameter of 80 mm, a lower diameter of 50 mm and a length of 100 mm to complete the tool assembly. Close the form. The tool is now displayed in the Explorer tree with the marker indicating that it is active. Tools can also be saved to a database and reloaded when required. Select the tool database icon. If we search, we can see that the default tool database is empty. Let's load a sample database. Select the Tool Database Manager icon, select Database Settings. From the folder icon, we can load the tool database in the Examples directory. Select the sample tool database.mdb file and select Open. Close the form and then search again. Note we now have a range of tools in our database. To narrow the search down, enter a maximum and minimum diameter of 50 mm and then search again. Select the TR50 tool and press Create Tools and then close the database. The new tool has now appeared in the project. We will use this tool for our roughing toolpath. As with tools, toolpaths can be created either by right-clicking on the Toolpath section of the Explorer window or via the ribbon in either the Home area or the dedicated Toolpath tab. Select the Toolpath Creation button and from the 3D Area Clearance section choose Model Area Clearance. Note that our workplane, block and tool are already defined. If you are not continuing from the previous tutorial, you may need to just recalculate your block as before. Autodesk Powermill has an incredibly high degree of toolpath control, and this form contains plenty of options to produce the desired toolpath. From the Model Area Clearance section, we will define the offset type to offset model. This will move the tool in towards the part, with the model defining the toolpath offset shape. Since we are using a 50 mm tip radius tool, we will use a 20 mm step over and a 3 mm step down. A 1 mm thickness means the toolpath will leave 1 mm of material around the part. Our tool is non-center cutting, so to protect it, the unsafe segment removal function will remove enclosed segments smaller than 95% of the tool diameter, preventing the tool from engaging its non-cutting region with unmachined stock. Automatic verification allows us to check against the model and stock as the toolpath works its way down the part. Any areas of collision will be automatically removed as the toolpath is calculated. For the rapid moves, we will calculate the clearance planes and modify the lead-in or approach to ramp into the part where possible. The final settings we will change are the feeds and speeds. Spindle speeds and feed rates can be modified to suit, for example from the tooling manufacturer's catalogue values. Simply enter the values for spindle speed, cutting feed rate, etc. The full feeds and speeds form can be accessed from the feed rate form icon, where cutting conditions can be set based on other factors such as surface speed and feed per tooth. Close the form and calculate the toolpath. Rapid moves, leads and links, and feeds and speeds can all be adjusted later without the need to recalculate the toolpath. This quickly generates a toolpath to remove the majority of the material. Note the warning indicates that some areas will have additional material than the desired 1mm thickness. This is as a result of our collision avoidance, so this is okay, since we will be performing some rest machining later. The toolpath slices can be viewed using the Dynamic Section tool. Set the axis to be in Z, switch the back plane on, and move its slider to the right. Lock the planes together, and then move them left and right to see the toolpath slices. Close the form. Autodesk Powermill has a range of powerful toolpath editing tools. On this part, it is likely that these corners would be machined in a different operation, possibly from the other direction. So we have some toolpath segments that we wish to remove. This is a very quick process. Hide the model for clarity and then simply select the segments you want to remove by holding down the left mouse button and dragging over them. Hit the Delete Selected button in the ribbon from the Toolpath Edit tab. This can also be done from the context-sensitive right-click menu by selecting Edit, Delete Selected. Continue until all the unwanted segments are removed. Note that any leads and links that are required will be automatically generated. We can now save the project for use later to complete the tutorial.